All right, the lesson for today is pretty easy. Basically, we're going to be talking about using the energy equations that we have. And we have two, right? We've got this P equals mgh, pardon me, and we have Ke equals 1/2 mv squared. They're pretty straightforward. I'm not, so I want to focus on PE. This is pretty much a plug and chug. And just remember when you're doing this, right, your G is 9.8. So I'll just do a brief thing here real quick. If you had imagine you had a box that was 3 kilograms and it was 2 meters in the air, and you wanted to find its potential energy, you would just say PE equals mgh. So that would be a mass of 3, a G of 9.8, an H of 2. 3 times 9.8 times 2 is 58.8 joules. So that's how you calculate potential energy. It's easy. Kinetic energy is just a little bit more complicated because you got to watch your order of operations to make sure that you deal with your squareds correctly. So let's say here in this case that I've got a 900 kilogram car, and I'm going to say that it's running with a velocity of 3 meters per second. So taking a look at this, I would have Ke equals 1/2 mv squared. So 1/2 900 times 3 squared. And the only thing to be careful about is if you remember your order of operations, which you may have learned from your math teachers using the mnemonic PEMDAS. We have to do parentheses. Although I've drawn parentheses here, I don't have pairs of numbers in parentheses. And then we do exponents. So I have to do my 3 squared before I do anything else. So 3 squared is 9. So I've got parentheses. I've done the exponents now. Now I do the multiplication. So now I can do the 1/2 times 900 times 9. So in this case, I would get 4,050 joules for a kinetic energy. But just make sure that you follow your order of operations and do your exponents before your multiplication. I'm only going to do one other one, and you may not need this, and if you feel like, well, let me show you what the problem is first. So I'm going to say, what if I told you the kinetic energy? So I'm going to say, here's going to be a runner now. Can I draw a runner? Not really, but okay. I'm going to say that this is a 60 kilogram runner, and I'm going to say, let's say that he's running, 1 second here. I'm going to say that he's running so that he has a kinetic energy of, I'm going to say 19,000 joules. Actually, that's a lot. Let's say 8,000 joules. So the other thing you can do is run this backwards. Now, if you feel confident that you could run this backwards, you can go ahead and stop the video here and go into check for understanding. But I'm going to do this one real quick because I want to make sure that you know how to solve a problem when you're looking for the velocity. So in this problem, if I wanted to find the velocity, use Ke equals 1/2 mv squared. I have 1/2 times 60 times, this time I don't know v, so I leave v squared. And the Ke is 8,000. There are a few ways of doing this. I think what I would do is I would do my half of 60 first. So I've got 8,000 equals 30v squared. And then I've got to kind of do PEMDAS backwards. So I've got to get it so that my v squared is by itself first. So I'm going to start by dividing both sides by 30. And I'm getting 266.67 equals v squared. And then the last step is to square root both sides. And I'm left with a velocity then of 16.3 meters per second. All right, that's all I got. There's 3 problems for you to look for in the check for understanding. So go ahead and give those a try. I will just point out to you in the check for understanding, in order for Schoology to grade it, you have to leave your units off. So don't put any units with your answers. All right, stay warm today.